viewers, welcome to this session on Introduction to Natural Hazards and Disasters, which forms the first part of the module of MEV 002 Environmental and Occupational Hazards. I introduce myself as Dr. Sushmita Bhaskar, working in the School of Interdisciplinary and Transdisciplinary Studies, Indira Gandhi National Open University, New Delhi. So first, let us define natural hazards as well as disasters. Now the objectives of the first module includes the definition of natural hazards and disaster, that is, after listening to this module you would be able to understand and define the terms of hazards and disaster and explain the types of natural hazards and disasters with some case studies. Now the earth processes, if you take, they have been operating throughout the geological history. But these processes have become hazardous only because they negatively affect us. So the earth is an open system with respect to energy, and it is a closed system with respect to the materials. The earth is also a dynamic evolving system with complex interactions of internal as well as external processes. Now in the internal processes, primarily these processes are responsible for the movement of plates, for the occurrence of earthquakes, and also for the volcanic activities. The external processes, that means something which is external. So these are responsible for wave generation. It could be for the floods, for hurricanes, for the tornado and the drought formations. So where does all the energy come from these two processes? The source of energy for the internal process is essentially radioactivity, and the source for the external process is the sun, that is the solar energy. Now, how do we define a hazard and a disaster? A hazard. This can be defined as a potential threat to humans and their welfare and risk as a probability of hazard occurrence. A hazard can also be defined as those elements of the physical environment which are harmful to man and caused by forces that are extraneous to him. Now a hazard has a potential to cause harm. Okay, it could be to people, to property, to the environment. So to people it can cause death, it can cause injury, there could be disease, and also it can cause stress. Human activity. So it can also cause economic loss, there could be educational problems and losses that are incurred. Then for the property and infrastructure there could be some kind of a damage, there could be economic loss, and in the same way to the environment. There could be loss of fauna and the flora. Then there can be pollution of various kinds. They can also cause loss of essential amenities. Now a disaster. This occurs when an extreme event exceeds a community's ability to cope with it. So this is a way we can define a hazard as well as a disaster. Natural disaster. So this is a hazardous event. You can see in the photographs that are shown here. This can cause unacceptably large numbers of fatalities and or overwhelming property damage due to natural processes. For example, there could be flood and rains, and as a result there could be a hazard. There could be primary, secondary and the tertiary effects, which we would see in the following slides. Dimensions of a hazard. Now the impact of a disastrous event is a function of its magnitude, that is the amount of energy that is released, and also the frequency, that is the recurrence interval. All this is influenced by other factors like climate, geology, vegetation, population and also land use. Magnitude. This is also a very important characteristic for analyzing the hazards, because only occurrences that are exceeding some defined level of magnitude are considered hazardous. The level of the harm, that is also a very important factor that we should know. This is governed by the magnitude of the hazard, by the frequency of hazard or recurrence, the intensity of the impact point. For example, in the earthquake, we see that there is an epicenter, and also the magnitude. Even we find that on the Richter scale or on the Macaulay scale, we find that there is a certain level or a grading that they give for an earthquake. So how big is that earthquake? Then in general, the frequency of an event is inversely related to the magnitude. We can classify natural hazards. So for example, natural hazards such as earthquakes or floods, they arise from purely natural processes in the environment. There can be quasi-natural hazards such as smog or desertification, and this arises through the interaction of natural processes and human activities. Technological hazards. This is due to the influence of man. They can be as a result of the human activities. This may be due to the toxicity of pesticides to fauna, to human beings, the accidental release of chemicals or an explosion from any nuclear plant and so on. So they arise directly as a result of human activities. Now in the natural hazards, we can classify them as geologic. The examples include earthquakes, volcanic eruptions, landslides, avalanches, subsidence and impacts with the space objects. Hydrological, this could be floods and tsunamis. Atmospheric hazards, they include hurricanes, tornadoes, droughts and severe thunderstorms as well as lightning. Biological, insect infestations, disease and wildfires are some examples of biological hazards. Technological hazards, which we just discussed now, this could also be due to the exposure to hazardous substances such as radon, mercury, asbestos fiber and coal dust. Also acid rain can contaminate the atmosphere and surface waters. So these are some examples of natural as well as technological hazards. Secondary hazards. These follow as a result of other hazard events. For example, if the primary hazard is an earthquake, the secondary hazards include the collapse of a building, there could be dam failure, there could be fire, there could be hazardous material spills, interruption of power supply, interruption of water supply, communication could not be restored properly, transportation may be affected, waste disposal can be a problem, landslides can occur, there can be soil liquefaction, tsunami and also water pollution. So these are all the effects due to the primary hazard. The secondary effects can be caused like so on. Chronic hazards. These are a group of hazards that do not stem from one event but they arise from continuous condition. For example, famine, resource degradation, pollution, large scale toxic contamination. So all these it takes a lot of time. This can accumulate over time and then they cause the chronic hazards. Hewitt and Burton in 1971 reported that a number of factors relating to damaging geophysical events are noted, and they include the aerial extent of damage zone, the intensity of impact at a certain point, duration of impact at a point, rate of onset of the event and predictability of the event. Now natural hazards can also be classified into rapid onset hazards and also the slow onset hazards. As the name indicates, rapid means they do not give you any kind of warning. There is literally no warning, but that just occurs all of a sudden. For example, volcanic eruptions, it could be earthquakes, landslides, severe thunderstorms. So they strike rapidly. But when it is slow onset, they take years to form, like disease epidemics or droughts. So they take a number of years that can form. So that is why they are referred to as slow onset hazards. Now the speed of onset of a hazard is an important variable since it conditions the warning time. It can give you the warning time and signals to be prepared. At one extreme, the earthquake, the landslides and flash floods give you literally no warning, and on the other hand, the tsunamis, typically they can give you warning periods of minutes or hours. Hurricanes and floods also, where the likelihood of occurrence is known several hours or even days in advance. Volcanoes can also erupt suddenly, but usually they give indications of an eruption weeks or months in advance. So these are the differences between rapid and slow onset hazards. There are also other hazards such as drought, desertification and subsidence which act slowly over a period of months or years. And the hazards such as erosion and sedimentation, they can have the varying lead times, so damage can occur suddenly or it can also develop over many years. Spatial dispersion. This refers to the pattern of distribution of a hazard over the geographic area in which the hazard can occur. Temporal spacing. This refers to the sequencing and seasonality of events. Some events are quite random, for example the volcanic eruptions, while others have seasons like hurricanes, the river floods and also tropical cyclones. They are seasonal in nature. Hazarscape. It is a landscape of many hazards and the interaction among nature, society and technology at a variety of spatial scales creates a mosaic of risk that affects places and the people who live there. The term is referred to a specific place or a region. Now this table gives you the disaster time and space characteristics. For example, on one side you can see the type of disaster, for example earthquake, landslide or drought, the impact time and also the spatial extent to which it occurs. So earthquake, it could occur in seconds to minutes, and the spatial extent could be ranging from 100 to 104 square kilometer. Another example I give you from the same table is cyclone, which can give you an impact time of few hours, and the spatial extent would again be 100 to 104 square kilometer. So that is why disaster time and space characteristic also form an important parameter for research and studies. The type of natural hazards, as we have discussed, they could be classified into several broad categories. So geological, basically they are driven by the geological or the earth processes, in particular the plate tectonics. And these are beyond the human influence, though human beings have a large influence on the impacts of these events. Meteorological, so they are driven by meteorological or the weather processes, and those particularly related to temperature and wind. They include the heat wave, the cold wave, cyclone, hurricanes and the freezing rain. Hydrological, they are driven by the water or the hydrological processes, and the examples include flood, droughts, mudslides and tsunamis. They can cause extensive damage to agriculture and are among the main contributors to famine also. Biological, so these are driven by the biological processes. These include various types of disease, including infectious diseases that can spread from person to person and infect the entire human population. So this could be in the form of epidemics as well as pandemics. Some examples are the Black Death that occurred in the 1300s, and it was also referred to as a bubonic plague, and it killed 75 to 100 million people. Another one was the 1918 Spanish flu pandemic, and recently we have also seen the COVID-19 pandemic, which is also killing millions of people. So these are examples of the biological hazards. Now, so that we understand these better, I would give you a case study, that is a Bhopal gas tragedy of India, which occurred in 1984. This occurred on the 3rd of December in 1984 in Bhopal in Madhya Pradesh, and the Union Carbide company there was manufacturing carbamate pesticides, and the key component is methyl isocyanate. On that fatal day when this disaster occurred, none of the safety devices worked, and there was a functional failure of the vent scrubber outlet. Finally, there was violent chemical reaction in the tank, the pressure built up, the safety valves opened, and this released enormous amount of the gaseous and liquid MIC, that is methyl isocyanate, along with hydrogen cyanide and also phosgene. So all these are very toxic and they can cause skin irritation, especially the MIC that can affect the lungs, the skin, the respiratory system, gastrointestinal system, and it has also caused reproductive, teratogenic and mutagenic effects among the progeny. The cleanup of this tragedy, this costed $570 million, and suppose the safety devices had worked, and if that would have been installed, that would have costed only $1 million if it was installed properly before the tragedy. The after effects of this tragedy are still seen with people and children having genetic disorders. So this was an example of a technological disaster. Coming to the end of this module, you should also know the international attention and strategies. The International Decade for Natural Disaster Reduction was declared by the United Nations in the year 1990s. The primary goal was to reduce the loss of life to property, socio-economic disruption caused by natural disasters. In 1994, the Yokohama Conference put socio-economic aspects as a component of effective disaster prevention. Now, within this context, the IDNDR advised the UN member states to establish national platforms which would facilitate the general disaster risk reduction objectives to cater to the national and local conditions and implement the agreed policies and expand the understanding and perception of the importance of disaster risk reduction. Again, the International Strategy for Disaster Reduction aims to push the initiatives and cooperation agreed on during the same and developing new mechanisms as well as ensuring for further commitments from the policy makers. In continuation with this, the SENDAI framework for disaster risk reduction, which was endorsed by the UN General Assembly for disaster risk reduction between the period 2015 to 2030, still is there. And this was adopted on the 18th of March in 2015 at the 3rd UN World Conference in Sendai City, Japan on disaster risk reduction. Now this is a 15-year voluntary non-binding agreement, and it is a first major agreement of the post-2015 development agenda. Under this, 7 targets and 4 priorities are listed for action. It recognizes that the state has a primary role to reduce disaster risk. It also states that the responsibility should be shared with other stakeholders, including the local governments, the private sector and other stakeholders. So the goal of this framework is the substantial reduction of disaster risk and losses in lives, livelihoods and death. It also aims to reduce the disaster risk, including economic, physical, social, cultural and environmental assets of persons, businesses, communities and countries. So, giving a summary of this module, dear learners, now you would have understood the definition of hazards and disaster, the classification of the natural hazards, the type of technological hazards, one case study which was very important, and it was one of the worst technological hazard in our country, that is in India, the Bhopal gas tragedy. You have also seen some of the international attentions and strategies that have been carried out, and also the SENDAI framework and its targets and priorities, and how we can aim to reduce the disaster risk and also loss in life and property, and this requires the cooperation of all. Thank you.